So this is lesson 1.9, the first video, A, on addition and subtraction with fractions in elementary algebra. So what we're doing here, adding and subtracting fractions, one of the things that you remember when you've done this in the past is that the denominators have to be the same. And when you add fractions, you only add the top number, and the bottom number just stays the same. And then you can reduce it if you need to reduce it. The same thing with subtraction. If we were to subtract fractions, denominators must be the same. We subtract the numerators and we reduce then, and we get that answer. If we have something like example 2, where we have a plus 5 over 8, and we are subtracting 3/8, notice we have two fractions here. This is a fraction, and this is a fraction. Denominators are the same. We follow the same rule, and that rule is a plus 5 minus 3 over 8. Well, what can we combine here? We can't do anything with the a, so we leave it alone. And we do 5 minus 3 is 2. 5 minus 3 is positive 2. And we put it over the 8, so nothing else changes. If I have something like 9 over x minus 3 over x, exact same rules. Our denominators are the same, so we subtract our numerators. 9 minus 3 is 6, and our denominator stays the same. Now there are some times where we'll have multiple numbers that we're trying to add or subtract, such as example 4. And we just do it PEMDAS, left to right, addition and subtraction. We get 5 over 7 minus 9 over 7. And again, I like to do 5 over 7 plus negative 9 over 7. Take the difference between those, sign of the largest, and put the 7 on there. The denominator, once it becomes the same, it never, ever in the whole history of the universe changes when you do your addition and subtraction. So, what if our numbers are not the same? What if we have something like 5/12 plus 7 over 18? Well, before we can add those, we have to get it so that our denominators are the same. And there's certain tricks that you use, and you've all done them before, in order to get those to be the same. So here's the trick. You take the 12 and you use the factor tree, and you do the 18 and use the factor tree. And we did it in the last lesson, so I'm just going to write 2 times 2 times 3. And what I do with this is I look in the bottom, 2 and 2 and 3, 2, 3 and 3. And I look over here and I say, am I missing anything here that I have over here? Yeah. I've got 1, 3 here and I've got 2 over there. Well, I want another one over here. Top and bottom. Then I look over here and say, do I have anything over here? Do I have anything here that I'm missing? Well, I have 1, 2 here. I have 2 of them here. So I'm going to put another 2 over there, so I have 2 on both sides. Now I multiply that. Multiply that. 3 times 2 is 6, times 2 is 12, times 3 is 36. Multiply that. Multiply that. And lo and behold, you have common denominators. You can add the top number, put it over the bottom number, and you're done. Now this is different than many of you have been taught. And I do it this way because later on you're going to need to know how to do it this way. So there are other ways that you've learned to do over the years, and they work as well. But this one is going to be consistent all the way through. So let's say that you're taking something like 7/15 minus 3/10. Okay, so we're going to leave the top number alone, but we're going to write the bottom as product of primes. And I'm going to ask myself the same question. Am I missing anything here that I have over here? Yeah, there's a 2 here. I don't have a 2 over there. So I'm going to multiply this by 2 and the top by 2. Alright, I'm missing something here that I have here. I have a 2 and a 5. I don't have a 3 over here, so I'm going to put a 3 on top and bottom. So I end up with 14 over 30 minus 9 over 30. 14 minus 9 is 5 over 30, and when I reduce that, 5 goes into 5 once, 5 goes into 30 6 times, and I get an answer of 1/6 for my answer. Okay, so let's look at this one. This is example 10. I'm going to write it as product of primes again. Okay, so I've got a 3 and a 2. Well, over here I have 3 2's, and over here I have 2 2's. So I'm missing some 2's over here. I want to have 3 here, because I go and see where I'm missing. And this one has a lot more than this does, so I want all of them. Now I have 3. Am I missing anything else? Nope, I'm okay there. So remember, I have to do the same on the top. Alright, let's look at this middle one. I've got 3 2's. Am I missing any? I've got 2 here. I've got more than 2, so I'm fine. I've got a 3 over here, so I want a 3. Okay, now let's look over here. Well, I have 2 of these 2's, but these other guys, they have 3, so I want one of those. And these guys over here, this one has a 3 here. I'd kind of like to have that 3 here. Alright, so multiply this. Multiply those. That. That. Now I just add my numbers here. 13 over 24. Okay? And we're done. Now let's do some subtracting of fractions here. So let's look at example 11. We've got 3 minus 5, 6. Alright, so 3 is the same as 3 over 1. Whenever I have a 1 down here, I know automatically that the common denominator will be the one that I have right here, the other one. So I've got to change this 1 to a 6. How do I change a 1 to a 6? Well, if I multiply that 1 by a 6, it will turn into a 6. But if I do that on the bottom, I also have to do it on top. Okay, so basically what I was doing is saying, what am I missing that I have over here? Multiply the top, top and bottom by that. So now I have 18 over 6 minus 5 over 6. 18 minus 5 is 13 over 6. And I'm done with that one. Alright, so let's jump down to example 13. And example 13 has us subtracting. Okay, so again, 5 is a prime number, so it's going to stay the same. 6 is 3 times 2. So let's see what I'm missing. What don't I have here? Well, I don't have a 3 or a 2. So I'm going to put a 3 and a 2 there, and a 3 and a 2 there. Alright, I've got a 3 and a 2 here. What am I missing? I'm missing a 5. So I'm going to do a 5 and a 5. So I'm going to multiply those. 6x over 30 minus 5 over 30. Put them together. I can't combine those because of this doggone x, so I just write them as 1 and put them over my 30. And at that point I'm done. So when you have it in two separate fractions and the denominators are the same, put these two together and put them over one denominator, and we're good there. A couple more examples and we'll be done with this lesson. Let's look at example number 14. 14 wants us to add 4 over x plus 2 over 3. Alright, the one thing that you need to recognize here is you break these bottom numbers down into the product of primes. 3 is a prime. We don't even know what x is, so we can't break it down. But I do know that I'm missing a 3 over here. I've got one there, don't have one there, so let's put one here. And I know when I look over here, I'm missing an x. So I'm going to multiply top and bottom, like that. Multiply those. Put those together. Now remember what I said, if you have the denominators the same, you just put the top numbers together and put it over whatever that denominator is, and you're done. Alright, one more, and we'll call it good for problem set 1.9 or lesson 1.9. So we have x over 3, and we're going to add 5x over 6. Alright, product of primes. The 3 is already prime, 5x over 3 times 2. Okay, what am I missing? I'm missing a 2. Am I missing anything over here? Nope, got it all. So 2x over 6 plus 5x over 6 equals 2x plus 5x over 6. These two added together gives me 7x over 6. And I am done. So that's problem set 1.9.